and Kara. Just a quick reminder that Energy Shrink is a local DC-based firm, and we provide energy analysis on a variety of projects in the local area. We also provide BEPS compliance support to several clients in DC and Maryland. And so in the process of doing this work, we have come across some aspects that we felt were not so well understood, and we are sharing those with you. I'm going to, sorry. Was anybody saying anything?
Yeah, question. Do you guys do like energy analysis, like benchmarking and like energy evaluation on buildings? And if you guys are doing it, like, are they gonna be like funded, or like are you guys like how do you guys manage those things?
Yeah, we do that work, and in Maryland, our work is funded by, like, for example, Montgomery County has BEPS standards, and they fund our work to a large extent through the Montgomery County Green Bank. In DC, it is not. In DC, clients have to pay for it themselves. So it depends on the jurisdiction.
All right, thanks.
Sure. So I'll start us off, and then Kara Hausman, my colleague, will take over after a few slides, and we'll go back and forth a little bit today. So again, slide 40, please, Kara. So just a couple of notes about Energy Shrink before we begin. We work with innovative clients on decarbonizing buildings, and we, everything we do is for the mission of decarbonizing buildings. Our main office is in DC, and we are a certified women-owned small business at the federal level, and a DC CBE and a Maryland MBE. We are also certified in Virginia, which is our home state, where we were formed, and New York, and Massachusetts, and California, actually. Next slide, please. So we provide analytics such as energy modeling for LEED, state codes, and BEPS compliance, which we are about to discuss. We also provide green building policy advisory and research services. For example, we are doing a project with the DC Public Service Commission at the moment. So this combination of knowledge informs the services that we provide for energy analysis. With that, I'm going to, Kara, should I do the handover now or later? Maybe I'll go through the next few slides and then hand it over to you. All right. So before I dive into our content for today, I'll go over a few housekeeping items. So this webinar is being recorded, so please be mindful of that as we continue. Please keep yourself muted during the presentation. And we will hold a question and answer portion after we go through our material today. So please be sure to hold your questions for later on. And we'll ask you to either enter your question into the chat or raise your hand. There's an icon you can see on the image here on the screen. Am I seeing the right thing? Yes. So you can see the React button on the Zoom bar, and you can raise your hand there and ask your question. This is for the end. So depending on whether you're more comfortable writing your question or speaking up, you have both options to ask your questions. Next slide, please.
So I'll take over from here, if that's okay.
Yeah, sure.
So here is the agenda for today. So as mentioned in session 1, you guys all attended. This course has 3 main parts. So the DC BEPS, the DC codes, and additions and alterations. So in session 1, we covered the current and future requirements of DC BEPS, which was followed by a section on the current and imminent requirements of the DC building codes and how those align with BEPS. So today in session 2, we'll be doing a quick recap of session 1. Then we'll be talking about which laws apply to which buildings in DC. And lastly, we'll discuss the areas of the codes that get triggered with additions and alterations, including those alterations that are being undertaken for BEPS compliance. And in that, we'll also highlight some of the issues that commonly arise in the code applications that are submitted to the Department of Buildings. So this department is a fairly new department in DC, which focuses on the implementation of DC's ambitious requirements for buildings. We did actually speak to their staff about the common issues they see in these code submittal applications. So we'll be sharing their observations with you today. And as Smita mentioned, please hold your questions for the discussion period. And then please also note the slide number on which you have a question so we can easily jump back to it. And having said that, Smita also mentioned if you do have any quick clarification questions to maybe help you understand the material we are presenting, please just put them in the chat and we'll answer them during the presentation within that chat bar if we can. So now I'll hand it back over to Smita to give a quick recap of the first session.
Thank you, Kara. So I'm going to just take us over the first session materials that we talked about. We discussed the role that the DC laws, the Building Energy Performance Standards, and the DC Energy Code play in achieving DC's carbon neutral goals by 2045. So it's worth mentioning that the BEPS that we talked about last time with the multiple pathways to get to BEPS apply to existing buildings, and codes which are moving towards Appendix Z apply to new construction and major alterations. So they are sort of two parallel paths if you think about all of the building stock in DC. So both BEPS and codes are moving towards the goals outlined in the DC laws for a carbon neutral DC. Now, one thing worth noting is that once a new construction project receives its occupancy permit, it automatically becomes an existing building and is subject to BEPS. So you do your codes and Appendix Z, and then as soon as the building is occupied, you're under the BEPS regulations. So essentially, BEPS covers all buildings in operation. There are some exceptions based on the ownership that we'll discuss shortly. Next slide, please. So first, a quick recap on what we discussed for BEPS. Building Energy Performance Standards, or BEPS, set the energy performance criteria for the operations of all buildings. And currently, private buildings in DC that are larger than 50,000 square feet are required to comply with BEPS, or they will face fines starting in 2026. And the fines could be up to $10 per square foot, depending on how far you are from the target, which adds up to a lot, actually. So compliance with BEPS typically involves submitting energy performance reports and undergoing energy audits to ensure that your buildings meet the required standards. And in successive BEPS periods, DC is requiring successively smaller buildings to benchmark. Buildings smaller than 25,000 square feet have already been caught in that net. And then buildings smaller than 10,000 square feet will be required to. So each successive 5-year BEPS cycle for any given building, it's not only the size of the building that is reducing, which people are more familiar with, but also each successive 5-year BEPS cycle for any given building will be tighter to achieve carbon neutrality. And we should expect this updated standard for BEPS every 5 years. So we just want to reinforce that. So there are several compliance pathway options available to building owners to meet the BEPS compliance requirements. We already discussed them last time. They include the performance pathway, the standard target pathway, the prescriptive pathway, and the alternative compliance pathway. We discussed them in detail in section 1. So if you missed any part, you're welcome to look at the recording. Next slide, please. So similarly, a quick recap of the energy codes under which we discussed the codes and how the BEPS compliance overlaps with the energy codes. So to recap, energy codes are a legal set of requirements which outline the minimum efficiency levels for new buildings and renovations to ensure reductions in building energy use and emissions. Energy codes are a subset of the overall building codes, and focus on the energy performance of the buildings. Other parts of the building codes relate to other areas such as fire safety, electrical systems, structural integrity, and plumbing. The energy codes ensure that buildings must meet specific energy efficiency standards for the various systems in the building, which impact the energy use. So these features include the building envelope, HVAC systems, domestic hot water, and lighting. So finally, I want to emphasize this again, that it is important to remember that a building built to code is actually the worst possible building that you can legally build. The codes are setting the minimum standards. So it is strongly advisable to go beyond the code requirement, especially keeping in mind the progressively more stringent long-term criteria of BEPS standards, keeping in mind that final goal of carbon neutrality. So good planning and consideration during the early design phase of the building are crucial to ensure that buildings not only comply with the current DC energy code upon completion, but also remain compliant with the evolving BEPS standards throughout their operational lifespan. This will avoid, having to repeatedly upgrade the building. Next slide. So overall, it's worth keeping in mind the big picture when planning and designing buildings. At a high level, the DC laws, the BEPS requirements, and the code requirements are all leading to a carbon neutral DC by 2045. And that's the end of the recap. Now let's dive into session 2. Kara, would you like to take on the next slide?
Yes. So here, the application of the laws and requirements in DC is interesting because not all requirements actually apply to all buildings. So for example, DC has a large presence of federal buildings, which actually have their own rules. So we couldn't find a neat graphic or a data table that shows the total area of DC buildings that slice this into federal versus public versus private ownership. So we have actually created this bar chart here from various data sources to just get a high level view of the relative areas of the building stock by ownership type. So this will determine the laws and codes that apply to each. So starting from the top, the DC Policy Center tells us that DC has about 303,000 housing units. So of these, about 93,000 are single family units, and the rest, about 210,000, are multifamily. So any of those buildings larger than 10,000 square feet will be subject to some type of building energy standards. We also found from multiple other sources, both in the public and real estate studies, that the average housing unit area is about 750 square feet. So multiplying the two, we have about 160 million square feet of multifamily buildings in DC. And this is shown here in the light gray bar at the top. And again, I just want to emphasize, please take these numbers with a grain of salt. So we couldn't find direct references and had to combine several data sources to get these numbers, which is never totally reliable, but it will give us a pretty good idea. So next in the dark gray, we have commercial office space. So CoStar indicates that commercial offices cover nearly 180 million square feet. Meanwhile, the DC Policy Center sets this area at about 169 million square feet in its 2024 report. And it's worth remembering that some offices are being converted to multifamily space in DC, so this area may be shrinking. And DC's Department of General Services, or DGS, says that they manage about 20 million square feet, which is shown here in green, which is the color of the DC government. And this reflects buildings owned and leased by the DC government and managed by DGS. But it likely does not include buildings where DC may have financed 15% or greater of the building, technically making it a public building and therefore subject to those public building codes. So many such buildings are not being managed by DGS and are being managed by other parties. So the green bar here, representing DC-owned public buildings, may actually be a lot greater when we consider the floor area subject to laws for DC buildings. It's important to keep in mind, again, that the requirements for public sector buildings are stricter than the requirements for commercial ones. And finally, GSA tells us that federal buildings occupy about 96 million square feet in DC. So these are shown in dark blue and will not be subject to DC codes or BEPS requirements. They actually have their own federal requirements for BEPS and codes to follow. According to DMPED, which is the DC's Office of the Deputy Mayor Planning and Economic Development, the GSA controls a quarter of the total office market, which is 26%. Of course, nearly 100 million square feet of federal buildings in DC include a lot more than offices. And besides this, DC also has exceptions such as a fair number of foreign-owned buildings, such as embassies, which are not subject to any US energy laws as well. So based on this, let's review which DC laws apply to which buildings. So for the purpose of our webinar, which is focused on DC building codes and BEPS, the majority of DC building stock that would be subject to these requirements can be divided based on three main types of ownership. The code and building performance requirements change based on this ownership. So first, we have private sector buildings. As we know, all private sector buildings over 25,000 square feet are now covered under BEPS in Cycle 2. And those larger than 10,000 square feet will be covered in Cycle 3. For new construction and alterations, they are currently subject to the 2017 code and will be subject to Appendix Z starting in 2026. Today, we will also cover the Green Building Act, or GBA, which applies on top of those building codes. Public sector buildings are those that are owned by the district or funded by the district. Buildings are considered to be funded by the district if they, again, receive at least 15% of their funding from district sources. These are also subject to BEPS on an advanced schedule. So all DC-owned buildings larger than 10,000 square feet had to comply in the first BEPS period. In comparison, in the private sector, only those buildings that were over 50,000 square feet were required to comply in the first period. In addition, DC-owned or funded buildings also have to follow the Green Building Act, or GBA, and the amended GBA, which is actually the Greener Government Buildings Amendment Act, which we'll dive more into in a bit. Lastly, again, federal buildings are a separate category in that they're exempt from DC codes and laws. They are subject to their own set of requirements. So for example, the Federal Energy Independence and Security Act, or ESA, and P100, which outlines GSA's energy performance requirements, and multiple other executive orders that control the energy performance of federal buildings. So again, it's worth noting that emissions from federal buildings, which are managed by GSA, are included in DC's inventory. However, DC does not have jurisdiction over them. So in this webinar, we won't be discussing federal buildings too much. Okay, so coming back to DC, what is DC's Green Building Act? The Green Building Act is a set of requirements on top of the building energy codes. The district's Green Building Act of 2006, also known as GBA, establishes high-performance green building standards for public and private construction projects. First, it requires that all non-residential district public buildings must achieve the U.S. Green Building Council's LEED Silver certification level or higher. It also says that district-owned or financed residential projects that are 10,000 square feet or larger must meet or exceed the Enterprise Green Communities certification standard. Last, new private development projects that are at or above 50,000 square feet are also subject to the GBA, and they're required to meet LEED certification at the certified level or higher. Certified here is just the base level of the LEED certification. It's also important to note that if a project falls under the scope of the GBA, compliance with the GBA satisfies compliance with the Green Construction Code also. So we didn't get into this code in this webinar or the last one because it does not cover energy performance, but that is yet another set of sustainable building requirements in DC that covers aspects like site, water, and materials. And these are also covered by standards such as LEED, So meeting those standards under the Green Building Act puts the building in automatic compliance with that green construction code as well. So this graphic here, provided by the Department of Energy and Environment, provides a logic flow diagram to determine whether a project is subject to the requirements of the GBA. And if so, what requirements apply to it. So as you can see, the parameters of the GBA are quite a maze to figure out here. So which requirements apply to a building depend on the building use type, the ownership, the size, and the level of improvement if it's an existing building. The Building Innovation Hub actually also provides a DC Green Code tool that can be used to help figure this out more easily as well. And we'll have that linked later on. And I really encourage you all to, again, check out the several resources and tools provided by the Department of Buildings and the Building Innovation Hub to determine what requirements your building might be subject to. So here, there is another new district law that impacts the public sector buildings, and this is the Greener Government Buildings Amendment Act of 2022, also known as the GGBA. And this went into effect about a year ago on October 1st of last year. So October 1st, 2023. So this act amends the GBA of 2006 that we just discussed. As mentioned, the GBA covers public sector buildings above 10,000 square feet and private sector ones above 50,000 square feet. The Greener Government Buildings Amendment Act levies stricter regulations on public sector buildings on top of those DC codes and the GBA. It requires additional green building features for government buildings and other publicly funded buildings in the district. So as a reminder, a district funded project like discussed is one where at least 15% of the total cost is sourced from the district. So two key aspects of this act include the net zero energy standards and fossil fuel-free construction, which prohibits the use of fossil fuels in construction. So the net zero energy requirement is definitely the biggest change introduced in the GGBA. It mandates that the government-owned or financed buildings achieve net zero energy consumption, generating as much energy as they use. So this means that a public project will have to meet the Appendix Z requirements found in the 2017 Energy Code. And as discussed, Appendix Z requires projects to implement energy conservation measures to significantly reduce energy consumption, employ all electric building systems, and utilize renewable energy sources to meet the annual energy demand of the building. It's again important to remember that although only applicable to public buildings now, starting in 2026, Appendix Z is expected to become mandatory for all new construction and for any substantial improvements. Net zero energy buildings are designed to produce as much energy as they consume over the course of a year. And this is typically achieved through a combination of energy efficient design, on-site renewable energy generation, such as solar panels, and energy storage technologies. And the Act mandates that all government-owned or financed buildings in the district must adhere to these net zero energy standards. So this means that new construction projects and major renovations of existing buildings must incorporate features and technologies that enable them to achieve these net zero energy status. Building projects subject to the net zero energy standards will need to meet stringent design and construction requirements to maximize energy efficiency and renewable energy generation. This may include features such as high performance insulation, energy efficient HVAC systems, advanced lighting controls, and also integrated renewable energy systems. To ensure compliance with this standard, building performance will need to be monitored and verified over time. And this may involve regular assessments of energy consumption, renewable energy generation, and overall building performance to confirm that the net zero energy target is being met. While achieving net zero energy status may require upfront investment in energy efficient technologies and those renewable energy systems, the long-term benefits can be very significant. Net zero energy buildings typically have lower operating costs, reduced environmental impact, and enhanced resilience to energy price fluctuations and supply disruptions. GGBA requires fossil fuel-free operations in government buildings. So this means eliminating the use of fossil fuels for heating, cooling, and powering buildings. For completeness, fossil fuels are hydrocarbon fuels being extracted from the earth, like natural gas and petroleum. This prohibition of fossil fuels for building operations is in line with Appendix C. But in addition, it also requires the construction to be free of fossil fuels. This means no diesel-powered machinery, no gas-powered heavy-duty vehicles. This prohibition contributes not only to mitigating climate change, but also to improving the air quality in the district as well. The Act prohibits the use of fossil fuels in both government-owned or government-financed buildings. So instead of relying on fossil fuels, buildings covered by the Act must utilize renewable energy sources, such as solar and wind, and geothermal energy for their energy needs, whenever feasible. For example, new project design should consider making rooftop space available for a solar PV installation. Off-site renewable energy can also be used, but there are some limitations to this, such that renewable energy must be procured from a qualified electricity supplier that meets the standards set in DC's renewable portfolio standards. And renewable energy must be procured via a power purchase agreement for a minimum of 5 years for electricity generation from solar or wind facilities located in the district, Maryland, or Virginia. The Act also requires monitoring and verification to ensure that the requirements are being enforced. The Act again provides that when the district government is seeking to fulfill its facility needs, in other words, when the district is seeking to rent or purchase a facility, the district will give priority consideration to buildings that maintain net zero energy compliance and to buildings that fulfill or exceed the LEED New Construction 2.2 standard or the LEED CS 2.0 standard at the silver level. And this means that when the district government is considering locations for its offices, facilities, or other infrastructure projects, buildings that meet these sustainability criteria will be given that preference. So prioritizing such buildings, this Act incentivizes developers and builders to adopt sustainable building practices and invest in energy efficient technologies. Now, let's take a look at whether the Greener Government Buildings Act applies to federal buildings. The answer is no here. So federal buildings in DC are exempt from the GGBA, as well as other district building energy laws and codes, like Appendix C. Federal buildings are managed by GSA and have to comply with federal energy efficiency and sustainability requirements. And these are mandated by federal laws, regulations, and executive orders. A few examples include the GSA P100 facility standards, Executive Orders 13834 and 13693, and the Federal Building Energy Efficiency Standards. And these establish mandatory design standards and performance criteria for federal buildings. So the BEPS, DC codes, and GBA and GGBA content that we have covered applies to private sector and district buildings. And here I'll pass it back over to Smita, who will discuss alterations that trigger the DC Energy Code.
Very good. Thank you, Kara. Can you hear me all right?
Yes.
Great. So in this section, we will discuss some typical alterations and the conditions under which they would trigger the energy code. And, we've had this question in our mind ourselves, which is what led us down this path. So hopefully this is something that helps you as well. So in the development of this webinar, we wanted to understand areas where building owners were having difficulty with code compliance. And like Kara mentioned earlier, we also met with the officials at the Department of Building who highlighted some aspects of the code that are causing them challenges when they are reviewing the submittals. So we'll also touch upon these common issues that the DOB observes in project submittals related to the building alterations. Next slide, please. Okay, so the code states that major alterations must comply with the code. What does that mean? The building code categorizes alterations into 3 levels: level 1, level 2, and level 3. At a high level, level 1 and level 2 do not trigger the code, but level 3 does. So what is the definition of each one? Level 1 alterations include the removal and replacement or the covering of existing materials, elements, equipment, or fixtures using new materials, elements, and equipment and fixtures that serve the same purpose. So if you're simply, doing any of these 4 things, but serving the same purpose, it doesn't trigger the code. Level 2 alterations include the reconfiguration of space, the addition or elimination of any door or window, so you're touching the building skin, the reconfiguration or extension of any system, or the installation of additional equipment. So that becomes a level 2 alteration. Level 3 alterations are defined as those where the work area, so it would be like a level 2 alteration, but the work area exceeds 50% of the building area. This definition of a major alteration varies by jurisdiction. So in different states and jurisdictions, you'll see lots of different ways to define this. So it's important to understand that in DC, it is defined as a work where the work area exceeds greater than 50% of the building area being renovated. Another important consideration when we are experiencing the conversion of office to residential use, for example, is that a change of use or occupancy will also trigger code compliance. So the code states that altering a building's use or occupancy type, such as converting an office into a retail store or vice versa, may trigger the need for modifications, and these would need to meet energy efficiency standards tailored to the new purpose. So this can include adjustments to lighting, HVAC systems, insulation, and other building components to align with the energy code requirements. So now let's look at the requirements for some typical upgrades or renovations that we typically see around DC. Next slide, please. So the most common upgrades are lighting upgrades. LED fixtures are highly efficient compared to older lamps, and their costs have come down enough that most lighting projects have a 1 to 2 year payback. LED lamps also last 6 to 10 times longer than old bulbs. So you know how most commercial buildings, like we do these building audits, we walk into the supply room of a commercial building, and they have these shelves lined with replacement lights. So with LEDs, that lighting inventory can be much smaller because you don't need, the lamps are not burning out as often. So lighting upgrades are very common in DC. At the same time, I'll say that it's very surprising, but there are still thousands upon thousands of lights in DC buildings that are not LEDs still. So we need even more lighting upgrades. So what triggers code compliance requirements? When more than 50% of connected lighting load is being replaced, it triggers code compliance requirements. So it's, you have to actually do a calculation of the wattage and see what is your connected lighting load. So let's say you have 10,000 watts of lighting installed and you're replacing more than 5,000 watts out of that, that triggers the code. And the tricky part is that it applies even when only the lamps are being replaced. So as you probably know, new LED lamps are available for almost any existing fixture. You can simply buy a new lamp that allows you to take out your old lamp and put in a LED replacement for it, for almost any type of lamp. So if you change out more than 50% of the lamps, they have to comply with the code. Or the building has to comply with the code. And this applies to both interior and exterior lighting. There are some exceptions such as lighting for emergency, health and safety, and decorative lighting is also exempt. And what are the requirements of the code? The code specifies the requirements as maximum lighting power density, or LPD, which is essentially the maximum watts installed per square foot. So for example, offices are allowed a maximum of 0.77 watts per square foot, and apartments and condos are allowed a maximum of 0.48 watts per square foot for their permanently installed lighting, which is typically in the kitchens and bathrooms. So this is according to the building area method, which means that we would calculate the lighting in the whole building and compare it to the maximum allowed per square foot. There is a second method, which is called the space by space method, which sets limits on every space type. So for example, corridors will have their own limit, bedrooms will have their own limit, office conference rooms will have their own limit, and enclosed offices versus open offices have different space by space lighting limits. And the calculations have to be made by each space type. So this method is only used typically in special cases. Usually we prefer to work with the building area method. It's simpler. And there is also a third method, which is the energy cost budget method. In this method, we look at the whole building energy use as a whole, and then we can use trade-offs. So what this means is if one energy use is higher, but another energy use is lower, we can still be in compliance if we are under the energy budget on the whole. So imagine if you have an office with heavy use of lighting for some reason, but then you have an ultra efficient cooling system that makes up for that extra lighting energy use by saving energy on cooling. This type of trade-off is allowed, but it would require energy modeling to show whole building compliance. And actually, this is the most typical type of work we do when we are working on whole building energy models. We don't have to comply, with lighting separately, with HVAC separately. We just look at the entire building and compare it to a baseline model of the entire building. So the building would be exempted from complying if so this is now I'm talking about the third section on the slide, which is, when are you exempt from this? So the building would be exempted from complying if the lighting load being replaced is less than 50%. And this is a second condition. And if the replacement lights do not increase the lighting loads. So we are assuming here that most people are putting in LEDs, but they might actually be putting in, higher wattage lamps. So if your replacement lights increase the lighting loads, then you are, liable to comply with the energy code. So you might think, okay, if my lighting replacement is greater than 50%, but I'm putting in all LED lamps, keeping the lighting power density low, then I'm probably already in compliance, right? But that's not the case, because the lighting requirements include not only the lamp wattage, but also lighting controls. So this is an important part to understand. Next slide, please. The code not only has lighting power density requirements, it has lighting control requirements to reduce energy use, and it is pretty extensive. The controls include automated and manual controls, which is basically a light switch, right? Across various spaces in a building. The code applies to interior spaces, parking garages, special applications, and exterior lighting. So a word of caution here, even though we are sharing the code requirements with you today, we are only sharing what we consider the highlights of the code. Like we picked out the most, meaty pieces, which we felt would resonate with people and people must know about. But there are actually a lot of details in the code. And if you are following the code or you're trying to follow the code, our advice is that you should read the lighting section from top to bottom to ensure that you're in compliance when doing a lighting upgrade. And the same applies for other upgrades like systems or insulation. So a few examples of the requirements for interior lighting include that each space must have manual controls for all lighting. So that means a light switch. You must have a light switch for all lighting. And then for spaces up to 10,000 square feet, that means 10,000 or smaller, there must be a manual control visible and accessible. And for spaces over 10,000 square feet, each control should cover no more than 2,500 square feet. Another interesting point is that the manual on is required. So they don't want lights to be automatically on. You are required to design it in such a way that people have to switch lights on. Automatic on is only allowed if manual control poses safety or security risks. So on the other hand, on the flip side, automatic lighting shut off is required. All lighting must turn off within 20 minutes of occupants leaving. And this is really a setting on the occupancy sensor. If you're installing an occupancy sensor and it senses that somebody has left the room, you can set how many minutes it waits before it switches off the light. So the requirement is that the lighting must turn off within 20 minutes of occupants leaving, except in restrooms, which has a 30-minute limit. And I'm sure many of you know this, but occupancy sensors are also of various types. And the newer ones that are the better ones have infrared sensing. So you don't have to, wave your hands around to switch the lights on. As long as you're in the room and you're giving off normal human body heat, it will sense that you're in the room and the lights will stay on. So for areas with side lighting, which basically means walls with windows, where you have areas where you have windows on the walls and where the general lighting is over 150 watts in total, the sum of the lights installed is over 150 watts. Lighting controls must adjust the lighting based on the daylight. So daylight controls are also a requirement. Lighting controls must adjust the lighting based on daylight with specific dimming or control points. There are some exceptions that apply to areas with very tall structures, less than 20 square feet of glazing, retail spaces. They don't want dimming in retail spaces naturally, and buildings with lighting power within 80% of the allowance. So if you're within 80% of the allowance, you don't have to have this dimming. So there are similar rules for top lighting, which is basically skylights. And similar rules also exist for parking lights, exterior lights, and special applications such as guest rooms and hotels. Again, these are just some examples of a very detailed list of requirements for controls. And what we heard from the Department of Buildings is that this is one area that is often a problem area in code document submittals. So when you're working on your lighting or doing any lighting upgrade, please keep this in mind. Lighting power density and lighting controls have to be in compliance. Next slide, please. Window upgrades. So again, another very common type of upgrade that we see around the city. In general, alterations to the building envelope, that is the building skin, must comply with the requirements regarding insulation, air leakage, and fenestration as they apply to the specific parts of the building being altered. So insulation is naturally in the walls. Air leakage is through the walls. A lot of people don't realize, but air goes right through brick, cement, and gypsum board. So when we talk about air tightness, you actually have to use special materials. So there are requirements regarding insulation, air leakage, and fenestration, which is just a fancy word for glass windows and doors. So any alteration that you're doing to any part of the building envelope has to meet the code for that specific part that is being altered. So it doesn't kick in building compliance for the whole building, just for that part. And a common upgrade in older buildings is window upgrades. So if old windows are being popped out and new windows are being put in, then only the requirements for window performance will apply. So for example, window replacement with different glazing. So replacing single pane windows with double or triple pane options will require energy code compliance. Even upgrades to more energy efficient options, such as low E windows, necessitates compliance because of the changes in the thermal performance of the building. So if the new windows have a higher solar heat gain coefficient or U factor than the existing windows, this can potentially increase energy consumption. You want low U value and you want optimal solar heat gain coefficient. So the window performance factors in the code, including U value and the solar heat gain coefficient or SHGC, must be met. Switching framing materials will trigger compliance with the energy codes for windows also. Frames can be aluminum, vinyl, or wood, and the material selection alters the overall window energy performance. Some window upgrades may trigger energy code compliance with additional requirements beyond the window requirements. So for example, if your window replacement is impacting the wall cavity, so if you have changes like resizing the windows, that is enlarging or reducing the window opening, or if you're installing windows in new locations or installing skylights, any of this will trigger the code requirements for the roof and the wall. These changes can significantly affect the building's heating, cooling, and lighting needs. So if insulation is being removed during the process, it must be replaced in accordance with the current energy codes. And if a wall is being impacted, the alteration will have to comply with the insulation and air sealing requirements for the walls. Another example is adding operable windows for ventilation. So replacing fixed windows with operable ones will affect both the ventilation and thermal performance, triggering the code requirements in both those areas. So ventilation and thermal performance. Window upgrades that do not trigger energy code compliance typically involve changes that do not involve the wall cavity, or they do not significantly alter the building's energy performance. So for example, if you're doing a same type window replacement, just replacing an old window with a new one of the same size, type, and energy efficiency rating, for example, a single pane for a single pane, and your U factor and solar heat gain coefficient remain unchanged, there is no need for an energy code review. If you're installing screens or storm windows, so you're adding external screens, and because they are temporary or supplemental, they do not trigger energy code requirements. Another thing that does not trigger energy code requirements is cosmetic upgrades. So if you are painting or sealing around the window frames or installing window film for privacy, this can all be done without impacting the thermal performance and does not trigger energy code compliance. I actually have an opinion on this one because when you're installing window film, you can lower your solar heat gain coefficient below the optimal level. So in DC, we typically see around 0.35, 0.36 as the best solar heat gain coefficient, and your window film can bring it down from that level. And when you do that, you're going to improve your performance of the building in summer, but you're actually going to make it worse in winter. And because we are a heating dominated climate, even though we are getting warmer, we still use a lot more energy in heating. If you reduce your solar heat gain coefficient too much, you can actually increase your energy use for heating. So just be mindful that, it may not trigger code compliance, but if you care about the energy use, you want to not go too low on your window film for your solar heat gain. Another area that does not trigger code compliance is minor repairs, like if you're doing fixing cracked or broken glass with identical materials, or fixing window hardware like locks or hinges without altering the frame or the glazing. There is no requirement for code compliance. And then finally, the non-conditioned spaces. So areas like garages or sheds where energy performance is not critical typically do not fall under the energy code requirements. Next slide, please. Okay, this is another common type of replacement that we do in buildings, which is HVAC upgrades. So alterations to the heating, ventilation, air conditioning, and refrigeration systems in existing buildings typically do trigger energy code compliance for the equipment. So just for the equipment itself. So this would include direct replacement of existing HVAC equipment. The new equipment must meet the minimum efficiency requirements outlined in, the associated table in the code. And then if you're installing new cooling systems for previously uncooled spaces, which can happen as we are getting hotter, there are many buildings that are getting too hot for comfort, even in multifamily apartments. We are having to install air conditioning. When they do that, they must comply with the code. And there are various compliance paths. Like there's a simplified approach for HVAC, there's a prescriptive path, and then there's a performance path. But using one of these paths, you have to make sure that you're meeting the code requirements for the cooling systems. Another thing that can trigger the code is if you're altering existing cooling systems. So the cooling system must maintain economizer capability. So there are exceptions to this, but economizers are generally required unless exceptions apply. So if you're doing systems with capacities below a specified minimum, or if you have high humidity requirements in hospitals, or if you have residential systems with lower capacities, specific computer room setups, and water-cooled units with low capacities, then you may not require, the economizer requirements may not apply. But there are certain sections of the code dedicated to economizer requirements, and you should look at the requirements for the code. Again, this is for alterations to existing cooling systems. If you are replacing or adding new ductwork, they have specific code requirements for ductwork as well. And similarly, if there is new or replacement of piping, so for example, if you have a boiler and hot water piping going around the building, it also has specific code requirements. Now, there are specified exceptions for which compliance will not be required. And these examples include equipment that is being modified or repaired but not replaced, provided that such modifications or repairs will not result in an increase in the annual energy consumption. So again, same rule like with lighting. If your replacement and repair actions are not increasing the energy use, it does not trigger the code. So another exception is where a replacement or alteration of equipment requires extensive revisions to other systems, equipments, or elements, but it is a like-for-like replacement. So if you're doing a like-for-like replacement, it does not trigger the code. Also, if you're simply changing the refrigerant of equipment, that does not trigger the code. If you are relocating the existing equipment, does not trigger the code. And also for ducts and piping where there is insufficient space or access to meet the code requirements, there is an exemption for that. Next slide, please. So we're going to spend a little bit of time on the heat pumps as an example, because this is a very common alteration we are going to see as we electrify our buildings in DC. And heat pump upgrades trigger the energy code compliance because they generally involve changes that significantly affect the system's energy performance, capacity, and how it interacts with the building envelope. So here are some examples. If you're upgrading to a larger capacity heat pump, so if you already have a heat pump and you're just upgrading to a larger capacity heat pump to handle the higher cooling, more likely, or higher heating loads, it will trigger an energy code review. And a larger unit may require upgrades to insulation, ductwork, and even the electrical system to meet the efficiency standards. Another example is switching from a traditional HVAC system to a heat pump, which again, we are going to see a lot of. So converting a building's heating and cooling system from a conventional furnace and air conditioner type to a heat pump involves changes to the system's overall efficiency. And this will trigger energy code compliance, especially if the fuel source changes, right? So if you had a gas furnace or a steam boiler, and now you're going to electric heat pump, that will require code compliance. If you're installing a ducted heat pump in a previously ductless system, that will trigger code compliance. And this will impact your energy efficiency, air leakage, and thermal performance. So proper insulation and sealing of ducts would also need to meet code requirements. If you're switching to a cold climate heat pump, which is basically an upgrade, we don't really require cold climate heat pumps in DC. This is something to keep in mind, like cold climate heat pumps are marketed as, heat pumps that can work even in very low temperatures. But actually in DC, regular heat pumps, the newer models of the regular heat pumps are perfectly able to meet the heating requirements in DC. But if you are upgrading to a cold climate heat pump, which are typically designed for areas with very low temperatures, this will trigger the code compliance, and the unit will have to meet the efficiency ratings that are appropriate for cold climates. Another example is replacing an air source heat pump with a geothermal heat pump. So, which basically means the heat pump is drawing heat from the air versus you have your ground source heat pump that is using a network of pipes to pull up heat or cool from the earth. And if you're making that switch, going from air source to geothermal, it is going to trigger the additional code compliance requirements. Adding a heat pump water heater is another good example. So typically water heaters are not electric, or if they are the old electric type. So if you're installing a heat pump water heater to replace a traditional water heater, it triggers an energy code review because it changes the overall energy profile of the building, and it will need to meet the energy efficiency standards set for water heating. And final example is a heat pump replacement that affects the building envelope. So any upgrade that involves changes to the building envelope, like requiring additional wall openings, changes in insulation, or changes in ventilation, will likely trigger energy code compliance. Now, a few exceptions that do not trigger energy code compliance are those that involve minimal changes to the system's overall performance or building integration. So such examples include, again, like-for-like replacement, aesthetic changes, like cosmetic upgrades, like repainting or adding protective covers to your heat pump unit, which do not affect its performance or efficiency, relocating a heat pump, and then ducts and piping with space constraints, again, as we mentioned, and then upgrading the controls. So replacing or upgrading the control system of an existing heat pump, like its thermostat or control board, without altering the heat pump's capacity or efficiency, does not trigger code compliance, because they are not going to change the overall energy system. Next slide, please. This is another area, commissioning requirements, which we heard is a challenging area for design teams to meet. So this section covers the construction and operational plans, commissioning and testing for buildings, focusing on the system's performance. And compliance with commissioning is crucial to ensure that the systems perform as per the design. So there is a acceptance testing section in the code, and all projects must comply with it. For new construction and alterations over 10,000 square feet, project commissioning is required. So anything over 10,000 square feet must commission the following systems: HVAC systems, which must ensure that both mechanical and passive systems are being commissioned. And then building envelope systems, which verify the air tightness and moisture integrity. The commissioning must ensure that the building envelope complies with the building envelope commissioning section of the code. Lighting systems have to be commissioned to make sure the lights and controls are working as intended. Any fenestration control systems. So for example, you have these automatic shading devices, and sometimes you have dynamic glazing, like electrochromic or thermochromic glazing, where it changes based on the temperatures outside. All those have to be commissioned. Renewable energy systems have to be commissioned. Irrigation systems have to be commissioned. And then domestic and process water pumping and mixing systems are included in the commissioning list. Service water heating, of course, which is basically your water heating in commercial buildings. And energy and water measurement devices also should be commissioned. So this is called section 11 of the code. Every project has to meet the provisions in section 11, which means that all aspects of testing, verification, and commissioning are mandatory. And so non-compliance with this could result in construction delays or issues with energy reporting. And so if your building is undergoing significant upgrades, so for example, if your HVAC system covers 20,000 square feet or more. So for HVAC systems, this requirement kicks in when it covers 20,000 square feet or more. It requires the commissioning of the mechanical, electrical, and plumbing equipment. So this is a general rule in codes. I think I mentioned it before also. Typically, it requires compliance with whatever it impacts, and things that are not getting affected by it do not have to comply. So in existing buildings. So with HVAC systems, when they're covering 20,000 square feet or more, you have to commission the mechanical, electrical, and plumbing equipment. And for projects that install HVAC systems above a certain size, additional commissioning is mandatory. So the size is 480,000 BTUs of heating capacity or 600,000 BTUs of cooling capacity. You don't have to memorize this, it's in the code book, but the thing to remember is if you are installing larger HVAC systems of heating and cooling capacity sizes, it requires additional commissioning, which is actually a technical term in the industry where it kicks up a new list of checks and balances that you have to do when you're performing commissioning. So when you're commissioning a system, it's just a technical term for checking and making sure that everything is working properly. And usually the engineers will come in and go down a list to see what all is, there's a mandatory list of things they have to check. And when you do additional commissioning, there's another additional mandatory list of things they have to check. So above a certain size, that additional commissioning becomes mandatory. Under the building acceptance testing, the section specifies that testing is essential to verify the HVAC lighting and any energy devices are functioning correctly based on the design documents. So during the pre-permit stage, there should be a designated representative to oversee the entire process. And that person should review the construction documents to confirm the control sequences and sensors to make sure everything is in place. And then before occupancy, this is, when you're applying for the occupancy permit, we have to ensure that systems are installed and tested as per the manufacturer specs, including testing and balancing. And it is also required that we prepare a systems manual with full documentation for operation, maintenance, and warranties, which is typically given to the facility supervisor. Under the project, so this part that I just mentioned is under the building acceptance testing. And there are actually companies that do just testing and balancing work. Then there is the project commissioning piece. This is required to verify that the systems are meeting the owner's project requirements or the OPR document. And this involves independent oversight by a commissioning authority, as many of you might know, who are not affiliated with the design or construction firms. So it's always an independent authority. And activities for commissioning ideally start in the pre-design phase and continue through post-occupancy. This doesn't always happen. Many times commissioning agents are called just at the last minute when everything has been put in. But ideally, they should be involved in the process through the pre-design phase. So in the pre-permit steps, the commissioning authority reviews both the OPR, that is the owner's project requirements, and the basis of design to make sure that there are no conflicts and ensure that all the systems and goals are being aligned. And then they have two review stages at the 50% completion and the 100% completion of the construction documents. This is required by DC codes with detailed reports to ensure that the owner's project requirements are being met. So again, 50% CD, 100% CD is required. And then in the pre-occupancy steps, you have to ensure that testing and verification of the commissioning steps has been completed. And in cases where seasonal commissioning is needed, for example, heating versus cooling, some testing can be deferred, but it must be completed as soon as conditions allow. So a preliminary commissioning report must be submitted, including deficiencies corrected, and code violations must be rectified before submitting it to the authority. So, which is the Department of Buildings. So, and it says in the code authority having jurisdiction because it may vary depending on who owns the buildings, but because there are DCDGS folks as well sometimes looking at compliance. But in either case, the project commissioning is required under building codes in DC. Finally, there is the building envelope commissioning. That is usually another party. Mechanical system commissioning is done by a certain type of companies. Building envelope commissioning is typically done by a different set of people with very specialized expertise in building envelope commissioning. And so in DC, buildings over 50,000 square feet are mandated to perform building envelope commissioning to ensure airtightness, energy efficiency, and compliance with the standards. So DC has very strict airtightness requirements actually, and air leakage should not exceed 0.25 CFM per square foot under a pressure difference of 75 Pascal. This is just, again, you don't have to memorize it, but it's in the code. But it's just to be aware that there are limits set that under a certain pressurized condition, the air, there cannot be over a certain amount of air leakage, which is very similar to how passive house standards are set. And passive house applies to both residential and commercial buildings, unlike its name. So this is along those lines of passive standards, and it's in Appendix Z as well. So it's good to be aware of it. So this is part of the building envelope commissioning, and building envelope commissioning authority, which is again the formal name for the third party that will commission the envelope. They have to be contracted. It's a requirement to oversee the process. And then the design review ensures, that is the purpose of the building envelope commissioning. It will ensure that the air barrier is well defined and there are provisions for field inspection and testing during construction. So it has to be, unlike systems commissioning, this is something that a lot of people don't realize, but building envelope commissioning can be pretty expensive because unlike systems commissioning where the HVAC folks come in when the systems have been installed, building envelope commissioning requires the commissioning authority to come in at multiple stages of the construction because they have to make sure all the water leakage and air leakage details are being put into place before the building gets clad and covered, and you can no longer see those details anymore. So it can be a very detailed multi-stage process and it can be a bit expensive. So it's good to be aware of that and be prepared for that. Next slide, please. So finally, again, we are talking about renewable requirements. This is the final slide on this section on what triggers code requirements. And we kept this one because this is also very popular in DC, and especially because DC pays really, really well for SRECs. So which are the solar renewable energy credits. A lot of people are installing solar systems. DC is paying upwards of $400 per megawatt hour generated. So we are seeing a lot of PV systems being put in. And the prescriptive renewable path, there are, several paths available for people to comply with the code. There is either a standard renewables approach or an alternate renewables approach available to people. And so the prescriptive renewable path establishes the requirements for new construction, additions, and major alterations that exceed 10,000 square feet. So when you follow this path, you have to either comply with the standard renewables or the alternate renewables approach, which incorporates more efficient equipment. And these requirements are associated with on-site renewable energy systems. That is, renewable systems being installed on the building site and apply to new builds, significant additions, or alterations of 10,000 square feet or more, like mentioned. They must be installed to offset the building's energy use unless certain exceptions apply. Projects are exempt if the site does not receive enough solar radiation, and they have actually set a limit for it. So if the site receives less than 4 kilowatt hours per meter square per day, it is exempt from the requirements of the solar PV compliance. Projects can also be exempt if they commit to purchasing renewable electricity. So if you're purchasing renewable electricity with cumulative totals reaching 70 kilowatt hours per square foot of conditioned space. So, like if you have a community access to community solar or a microgrid, or you have a power purchase agreement where your totals, cumulative totals, reach 70 kilowatt hours per square foot of conditioned space, then you're exempt. Again, these are a lot of numbers, don't have to memorize, they're in the codes, but it's good to be aware that there are these exemptions possible if you have a way to buy renewable electricity. Under the standard renewables approach for compliance, buildings have to generate renewable energy based on their roof area. And single-story buildings are required to produce at least 6 kBTU per square foot annually. So it's a bit confusing because sometimes it's kBTU, sometimes it's kilowatt hours, but kBTU and kilowatt hour can easily be converted into each other. So this is saying the limit is set at 6 kBTU per square foot annually as the minimum. And multi-story buildings, it's set at 10 kBTU per square foot at a minimum. So this ensures that renewable energy production is proportionate to the building size. So in the alternate renewables approach, this allows for reduced on-site renewable energy production. So we just talked about how much you must produce at a minimum. You are allowed to produce less than that if your equipment is more efficient. So single-story buildings limit goes down from 6 to 4 annually, 4 kBTU per square foot. And for multi-story buildings, it goes down from 10 to 7 kBTU per square foot, as long as the projects are meeting the efficiency standards set by, there are ASHRAE standards called ASHRAE 189.1, including Energy Star requirements and water heating efficiency standards. So essentially, if your building is highly efficient, then you are allowed to produce less solar and still be in compliance. So in addition, the District of Columbia has adopted a couple of key provisions from the ASHRAE 189 standard into its commercial building energy code. And this is Appendix A, which sets minimum R values for duct insulation in heating, cooling, and combined systems, and Appendix B, which sets a prescriptive efficiency tables for alternate renewables and for the increased efficiency approach, equipment efficiency approach. So those are included for renewables. So to close this section, I'll go to the next slide. So I'll just underline the few areas that need attention when submitting code compliance documentation based on our discussion with the Department of Buildings. So in lighting, providing calculations for the lighting power density and providing the lighting controls compliance, clearly marking the lighting controls on the drawings is required. And drawings are often held for comments because they don't have enough correct lighting controls in each of their spaces. Something to keep in mind. Now, the second one is wall insulation, insulating the walls as per code whenever they are disturbed or altered. Mechanical system load sizing calculations. So this is something that the Department of Buildings is also finding lacking many times in drawings, is that the mechanical engineers are typically not providing the system load calculations except when they're asked, and it is required by code. Commissioning, as I mentioned, the team needs to provide evidence of commissioning. It's many times missing, simply missing from the code submittals. And finally, renewables. Renewables are a requirement in DC, and correct calculations must be provided. With that, I'll hand it back to Kara.
Yes, lastly, we just wanted to highlight a few resources that can be helpful when navigating compliance requirements and wanting to just stay updated on the latest news on these topics. So the Department of Buildings sends out a monthly newsletter and also has a newsroom page on their website. I also really encourage you all to check out the Building Innovation Hub and the Department of Energy and Environment's Energy in the District page. And these both really provide several resources and tools applicable to these DC regulations. And with that, that is the end of our webinar, and we will open it up for questions. And here is our contact information, which is included on this slide. So feel free to reach out if you'd like to follow up on anything.
I also wanted to mention, like, if there are any topics that you feel, we covered a lot of ground in these webinars, but if you feel like we left something out and you would want to know more about it, please let us know and we'll try to cover it in our training next year. And you can please add that to the chat as well.
So Aaron said in the chat, does construction budget also trigger code compliance, such as construction costs exceeding 100% tax assessment value?
I don't know the answer to this. We can look it up because in certain jurisdictions, that is one of the triggers, but I did not see that in the DC code. We can look into this though. I'll just copy and save this question.
And then Octavia said, can we get access to the slides? And yes, both session slides will be available. We'll clean those up. Get those over to all participants. And that's everything in the chat, but if anyone else wants to.
Please feel free to unmute yourself, put your camera on and ask questions. I see a couple of people had to jump off and they said their thank yous in the chat. So totally understand. It's, it's a working day. But if you have any questions, please speak up now.
I could have missed this, but are you guys actively doing audits in DC?
So we do building walkthroughs when we are looking at BEPS, building energy performance compliance for our clients. So we do benchmarking. The services we provide are benchmarking and studies for BEPS compliance. So what we mean by that is we'll do the utility analysis of buildings bills and a walkthrough of the building. So in that sense, it's an audit. We do a walkthrough of the building to understand the systems that are in the building. And then we do energy modeling to understand what the building could do to improve its performance. That's the sort of service we provide. There are companies that do just building energy audits, like they are typically set up differently. Like they have teams of people whose only job is to walk into a building, take the ASHRAE checklist. ASHRAE provides you with a checklist of things you should look at and measure. And the audits can be ASHRAE level 1, level 2, level 3. So typically when people say, we do building energy audits, what they're saying is that they do the ASHRAE level 2 audit, which is a very thorough checklist that ASHRAE provides for buildings. We do not do ASHRAE level 2 audits. We do a combination of ASHRAE level 1 and ASHRAE level 3. Sorry, I'm giving you a longer answer than you might be expecting, but I feel like
this is helpful though. This is really helpful.
So what we provide is level 1, which is a walkthrough, which is not like this entire checklist. And the level 1, we are just looking for things that we know are, likely the problem areas, as raised by the building utility bill analysis. And then the level 3 part of it is you actually take the information from the building energy audit and then you do the energy modeling, right? That gives you investment grade answers that you don't get from level 2. So we provide that level 3 analysis where we actually do the energy modeling and tell you, if you do this, you'll save this much energy and it'll probably cost this much. And then you can compare your options and see which one is the most favorable set of things. And sometimes it's not just about cost, it's also about, for various reasons, people want to alter one thing and not something else. So it just gives you a few options to work with. And it also helps to see what part of it is getting incentivized by IRA funds, for example, which could lower the cost for the building. So there are incentives provided by the DC government, through DCSEU. There are some incentives being provided by the gas and electric utility programs. So you can combine lots of different ways to finance some of these upgrades. So that's the sort of thing we do, like to provide those studies for actually upgrading our buildings.
Got it. Thank you.
I have a question. Hello, can you hear me?
Is there some kind of disturbance in the line?
I'm not sure, but my reception has been a little inconsistent, so that might be a factor. But can you hear me though, or it's not clear enough?
Yes, we can hear you.
You can hear me, okay. So my question is, energy modeling and commission. I'd like to know from your professional expertise and what you've been doing so far, overlap between energy modeling and commissioning of a mandatory system, such as the building envelope system.
Sorry, I heard only part of the question. I heard you're asking about building envelope commissioning and auditing, but I couldn't actually hear the question, the first part of it.
Okay. Are there overlaps between energy modeling and commissioning of the mandatory system, such as the building envelope?
So that's a great question. Typically, for building commissioning, building energy modeling is not required typically. But what we find very helpful is, like the previous question about audits. So I don't know, Manu, are you trying to say something or is that just a disturbance from the line? Okay, so thank you for muting. So typically, when you're doing commissioning, you're not required to do energy models. Energy models are helpful when you're upgrading a building and you are going to be investing, hundreds of thousands of dollars into your upgrade. At that time, if you spend a little bit in the beginning to evaluate your options, that's where energy modeling is the best use of your money. And what I find really helpful is to go in with our partners who actually perform the audits and commissioning. So we have done this on multiple projects where our client is asking us for a study or a report to tell them what upgrades to invest in. And we go in with our audit and commissioning partners who do a full study of the systems as would be required for ASHRAE. And then we take their information so that, we are not just looking at the building, we actually have all of the data to build our energy model. So that gives us much deeper information. It forms our energy model much better. So we typically partner with someone to do that type of work.
Thank you.
Sure. Yeah, but I would not recommend an energy model for a commissioning job. It's not required.
Noted.
Brooke, did you have a question? Just wanted to make sure. Any other questions? I'll give it another minute and then maybe if there are no more questions, we can wrap up.
Question.
Sure.
You hear me? Oh, so do you guys have another similar type of webinar or trainings?
So this year, this is the last one, except the other one you already know about, right? The GPro construction management. So that one is happening on September 24th and 26th.
Okay.
And actually, that's a good point. If anyone on the call would like to attend, if anyone is in construction management, it's also free. It's being offered on September 24th and 26th from 9 to 1 p.m., 2 days. And you are required to attend the webinar fully in person, not watching the recording, to be eligible to write the exam. But if you do complete that course and write the exam, you get a G Pro Construction Manager, that is a green professional construction management certificate. And it also qualifies you, like if you are on a construction team, that construction team gets a lead point for having a certified G Pro professional on their team. So you can actually use that on your resume as a selling point. You also get like AIA, CEUs, and so I can actually post the link for that event. I'm not sure if we have it on our website. We should definitely put it on LinkedIn. Let me give you the link to it. We can also put into the chat some of the resources that we shared with you today. Let's see. So I just put into the chat the session 2 for G Pro Construction Management. And then from our, on building codes, if you're ever looking for information, these are the 3 places that we recommend to stay on top of building code information. So it's the Department of Buildings and the Building Innovation Hub, which is a DC organization that actually pulls together all the pertinent information for BEPS compliance and code compliance, and also holds many events. It's a not-for-profit based in DC. They also list suppliers in the district, etc. So, and then of course the Department of Energy and Environment has their own resources as well. Like that very nice flow chart that we showed you. Any other questions? Actually, that's a good reminder. I'll put a reminder for the G Pro course online. I